Alright, it should be another draft physics video presentation. DraftScience here on YouTube. Different camera. Yeah, whatever. Computers. Anyway, so in the comments I was linked to this paper by some guy, you don't really know much about him, some Novak thing, Gary Novak. And he's making the argument that is, the same argument I'm making, basically that the 1/2 mv squared formula for kinetic energy is not the correct formula to use for energy, that momentum does give the correct answer, blah, 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 blah. There's lots of parts to it, but none of the arguments are at all the arguments I'm making, basically. I mean, they're not the same arguments. He clearly goes into rocket ships and how they work and all this kind of stuff, so those arguments are similar. But he's basically an etherist, apparently, and so he has a premise of what energy is that is driving, I suppose, this argument. And so yeah, it's good. Somebody else has got it right, so there's two people now that can figure out the truth. There's probably others that just haven't announced their vote. But it's so obviously silly, and again, I just go over it again. There's just absolutely no evidence where momentum gets the wrong answer. So I haven't gotten one experimental evidence, piece of data, piece of anything demonstrating that if I use the momentum formula, I'm going to get a wrong answer for how much energy something has. Never gets the wrong answer. Anyway, and so I'm going to once again illustrate the simple, I'm going to do some pyrrho comments crap. Because I talked to Pyrrho last night for about 10 minutes, and all we did was yell at each other because he won't stay on the subject. I mean, it's just no point. He has I have some obligation to believe that he says all force is measured over how much distance something travels. Or whether it's distance of the accelerating portion of the event, or, it's just, who knows what the hell he's talking about. But obviously I'm saying, yes, distance doesn't have anything to do with any of this crap. Energy has everything to do with it. To getting hit by force bits. You have to get hit by atoms. You have to get hit by electrons. You have to get hit by photons. They're the things that have momentum. They're the things that give you your momentum ultimately. They transfer it to you. Okay? Just that's what happens. The effect gets transferred to you. You catch the virus, so to speak, of the motion, the bias in a direction. So I will get to that whole force video that I want to make eventually. But let's understand, just because he refuses to deal with the paradoxes. So again, I have explained the paradox. You're just merely banging two trains into another train, connecting them with Velcro. Very efficient transfer. So the train is going 10 miles an hour, meters per second, whatever. And it weighs 5 tons or pounds or whatever. And all you're doing is inverting that when you combine them. So when you connect the two into each other, you just convert it into a 5-mile-an-hour train going weighing 10 pounds or whatever units. So it's just an inversion, okay? The experiment is classic. It's used by maybe hundreds of physicists on YouTube. This example is used. It's their physics and how they describe it, okay? So the simple argument is, if you understood the velocity is the only thing that can, you're changing mass, but you're not losing mass or extracting mass or doing something like that. So you're not losing it to the environment. And the real key factor is the velocity is the thing, it's the key. The only thing that you can give away to the environment is your velocity. That's the part of your momentum you can give away. You can lose. Can't lose the mass, you can lose the velocity. And so if you spill any of you lose any of your, in this transfer. So you had a transfer, you dumped it from one place to another place. The idea is that you had a 100% efficient transfer, because all of the momentum got here. The 10 is still here, the 5 is still here. You didn't lose any components at all. None. 0. Alright, that's the contention, clearly made in the videos. And then they say, well, this object had 500 joules of energy, And this object now, the new object, only has 250. And they pretend that somehow they lost it to the environment. Like there was a bunch of noises made and sparks or something. If any sparks happen, this number has to go down. If I make a single sound, this number has to go down. If I squish a single frog, this number has to go down. I do anything at all to shake the tracks, vibrate the earth, make air move, this number has to go down. So you cannot premise an argument by saying I completely transferred the momentum and then say, but I lost half the energy. 1/2 the energy gone. Half the energy of a 5-pound object moving 10 meters per second is a lot of energy. You have to explain where it went. You can't just say, I lost it. No, I didn't slow down. I didn't lose any velocity because I have exactly the proportional amount of velocity for my increase in mass. So I conserved transferred successfully all of the momentum, so I couldn't have come out of my momentum, couldn't come out of the energy I started with. I lost half of something I couldn't even have as a starting point. So anyway, obviously this number is just fake. There's no such thing. All right, anyway, but that's the paradox. I mean, it's a clear paradox. It's clear nonsense. I can't pour all of the water I have in a bucket. I can't pour it into another bucket. And I have to have poured it all into the other bucket or the bucket wouldn't be full. Right? It wouldn't have the right number. I can't pour it all into the bucket and then say I spilled half of it. That's the paradox. That's the unresolved, unstated, unexplained paradox. You can't do that. It's not physics. It's not rational. It's an irrational proposition. It's more preposterous than a UFO theory. It's more preposterous than you can't get more extraordinary as a claim than to claim you magically lost the energy. And again, damn this thing. I could apply the simple extra condition. I'm really gonna someday, Wire, you're gonna really get yours. I'm so gonna kick your fucking ass. I'm gonna throw you right in the garbage, you bastard. Someday. So the simple conditional I can add to this is I take this cart that only has 250 units of energy. I take that cart and I just bang it into a spring, right? I always have to do this thing. It doesn't show. So I can just take the 250 cart, the one that lost half the energy, and I just bang it into a spring, collect the energy, that is, stop the spring at the most compression, and then I just replace it with the original cart, and it shoots it out at 500 joules again. So how did I lose the energy? How can I possibly recover the energy again? Because this heavy cart going slow will compress the spring just as much. It'll give you just as much energy as this 500 joules. So it's an insipid paradox. So stupid. Can't possibly be the right answer. The only possibility is it's the wrong answer. It's the wrong definition of energy. Clearly. All right, so he says, I know the history. Well, I don't really think you do. You're not appreciating it. You're not explaining it. It's so bad. You're not accounting for it. Joule is the key. So again, that came much later. So that's just more nonsense. That's just baby talk. The interesting thing is the Joule-Newton thing, right? It's 100 grams is a Newton. Just the weight of 100 grams. So the amount of gravitational force, okay, on 100 grams is a Newton. So the weight of that. I drop the 100 grams, the stick of butter, and it's the landing amount of energy that is a joule. So the simple thing to do is just take a stick of butter and drop it on a scale. I have to see if my electronic scale will work. And then we'll know how much a joule is. Exactly. How much it weighs. Because that's all it really is. All the forces are weights. All forces are pressures. All forces are pushes. And so you could just turn them all into how many pounds. And make it so much simpler. But anyway, looking for the relationship between the heat needed i.e. burning wood in a boiler to move something. So again, he's talking about the steam engine. So he's obsessed with steam engines, and this started with the boring cannons. And they realized when they bore cannons, they create a lot of heat. They're trying to, they're just scraping out the iron, and that creates heat. And somehow they think it creates magical heat, that the heat isn't directly related to how much torque and how much friction you're creating with the blades of the cutter. I mean, of course it does. Well, anyway. See, I mean, we have to all think back to people. These are back in days way before electric light bulbs, way before, we knew a lot of stuff. And so to them, it was a surprise to figure out that heat is a form of energy. All right, force, distance. You see, so again, he's obsessed with force and distance. He won't allow anybody to talk about physics in terms of force and time. That's not allowed. It's not how long you're in the gravity. It's just how much distance you travel in the gravity. When I obviously would make the simple argument, no, it's all about how long you're in the gravity. We can say, see, even their physics. I'll do that eventually. The Wikipedia page for maybe a joule, and they have all the conversions. And examples, and they do some of them using the kinetic energy formula and some of them using the momentum formula, which is hilarious. So the units are all wrong and different. The comparisons. And what was the key point there, though? Force, distance versus time. There was something that was critical here. Oh yeah, they talked about lifting 100 grams 1 meter. The amount of energy it takes to lift 100 grams 1 meter. Well, isn't that the catch? Because if I'm only moving it the 100 meter, I could move it 3 meters and at a much higher velocity, and then you can only count the first meter I moved it. It would be less energy because I wasn't in the gravity as long. So if you don't consider, and say if I move something really slowly, you do realize you have to continually accept the force of gravity of the object. So the amount of work you're going to have to do to lift something slowly, it's automatically more work. So they put no conditional about how much time you took. Now, I guess obviously they meant 1 second, but they didn't say 1 second. All right, anyway. All right, force, distance you can make, just like going into a magnet. If I'm pushing two magnets together, while I'm holding it in one position against the force, it's still putting pressure on me, right? So, there's still force. So I could sit there and just hold it for 10 minutes and I'm doing work, even though I didn't accomplish anything, because the magnet's still pushing against me. I mean, it's like standing in the wind. If I don't move against the wind and the wind's blowing against me, it's still a force blowing against me. I still have to, lean against it. It's still work. All right, anyway, you can make a piston. It can provide a force to any mass in front of it. So again, this has absolutely nothing to do with the simple exchange experiments pointing out that your definition of energy it's not coherent to what the actual experiments will demonstrate. So why don't we just do the experiments and we'll know the truth. Okay, anyway, how much heat it will take. That is the new take on energy. So again, energy is just one form of momentum. That's it. It's just one of the forms of momentum. Gravity is a form of momentum. It's a force that acts on your nuclear bits. Photons hit your surface area. All the forces act differently. All of them affect things a little bit differently. They all have different rules. The steel balls, the force travels at the speed of sound. I mean, they're all different. It's just silly to say, I have one formula that answers all questions, when the only formula that matters is how much motion is there. The motion is the energy. All right. That was a new take on energy, because for a big thing to have motion, all of the little things have to move. That's all you need to understand. Is the total energy is how much energy does it take to move everything. The whole thing moved. That means every single one of your atomic bits moved. That means your mass, in terms of your atomic mass, is what is being moved. Alright, anyway. It can provide a force to any mass in front of it. How much heat will it take? That was the new take on energy rather than momentum. So again, there's two competing. You can sit there and say momentum gets a wrong answer. You'll never show me momentum getting a wrong answer. So you'll never give me an example of any heat equation, any equation anywhere, any circumstance anywhere where momentum will get you the wrong answer. It'll only get you the wrong answer if you put the wrong variables in. If you tell me the wrong amounts. You tell me something weighs a Newton when it weighs 4 newtons. Something like that. And how things will keep moving, it was about applying your piston to other forces over space. So again, what does this have to do with any of the last 40, 50, 60 videos I've made? Absolutely nothing. That leads to the F times D. So again, this force times distance thing is absolutely, we're already defining what the energy is. That's already the force. You can't put the energy in what you're trying to define. You can't say energy equals energy. And that's essentially all you're doing. All there is force. The distance is irrelevant. It's a certain amount of force. And forces are more than how much distance did they move you. We know it's easy to move light things. It's hard to move heavy things. So we know it's not the same force. So why are we pretending those would be the same things? That distance would be a measure of how much force was applied. Of course it's not. All right. Let's see, the amount in question. How much F times D does it take to push something for D feet? So again, it's just silly. Push it against what? You have to be pushing against some other force, some friction, some tension, some gravity. This isn't an equation that has anything to do with transferring energy. I mean, it can't. I'm just saying. If this isn't what the definition of evasion is, then what is? He hasn't addressed a single one of the experiments I've demonstrated the paradoxes in, and he's doing this crap that can't be related in any way. All right, push something to defeat in different. Let's see. D does take to push something for D feet that leads to the different units. Says you. But momentum wasn't sad. I don't know what that means. But momentum wasn't sad. It was going to endeavor to persevere. And in the end it will win, even though it has to fight all of you religious kooks. I don't know what it meant. Isn't sad. Momentum is still related to energy. In what way? It's not anymore. You've ruined it. You've replaced it with nonsense. All right, anyway. And the issue is momentum exists in 3 dimensions and has a direction. So again, this weird thing, he says the weird things, there's only weird things from your perspective. There's explainable things from my perspective. Anyway, the weird things that you hate are really just 3-dimensional momentum vectors, vector behavior, versus just a number of scalar energy which doesn't have direction. So again, I've already talked about that this is just ridiculous to say the energy in the train transfer or the energy in the Newton's cradle, that it doesn't have a direction. Of course it has a direction. So why even play this ridiculous game? The two formulas have exactly the same 2 components, mass and velocity. All you're doing is putting 2's and 7's in front of them. Okay, those 2's and 7's can't make the difference between a scalar and a whatever you call the other thing. Can't make any difference. It's just absolute nonsense. It's like the momentum carries the energy. There's just no point. No. Momentum's an explicit statement about how much the thing is capable of moving matter. It's clearly a definition of energy. Momentum is the kinetic storage of energy. No, it's really not storage in the sense that it's actively carrying it. And it will actively dump it on you at any moment. Just put your hand in front of it and the momentum is ready to be delivered. It's just, this is no point. Momentum is the kinetic storage of energy. Yeah, whatever. If they're 2 different numbers, then they can't be anything like the same thing. Your theory says the energy of 2 objects that have exactly the same momentum, they can have somehow different energy. How can the thing carrying the energy carry different amounts? It doesn't make any sense at all. It's just gibberish. Momentum is the kinetic storage of energy, but there's tons of other ways to store it. So again, this isn't about storage. It isn't about potential energy. It isn't. There's no such thing anyway. It really isn't. Nothing can have potential energy. Realistically, it can't have it. It has to wait for the potential energy to act on it. Okay, when you are sitting on the top of a mountain, you have potential energy from gravity. You don't have it. You have to wait for gravity to actually start accelerating you, and it takes time to accelerate you and all that stuff. It's not energy you have. It's gravity's going to impose it. It's going to fill you full of it. Anyway, more way to study shoving things with forces over a distance is a compressed spring. I wish you would stay on that subject, maybe. The spring gives a force that is stronger the more it is condensed. Yes, so it's perfectly proportional, but obviously the proportion is on one of those curves. It gives back more the deeper you go in, but it always gives you a consistent amount for a consistent amount of depth. So, no matter how, you compress it the same amount, it'll give you the same amount back every time. The spring gives a force that is stronger the more it's condensed. Yeah, we know that. So what? What does that have to do with squaring the distance? It has absolutely nothing to do with saying the same spring shoots two objects. One object's light, one object's heavy. You're saying the light object acquired more energy. The F from the spring is K times D. Who cares again? D is the amount of compression. Again, who cares? We already know we're giving objects the same compression on the spring. The spring's not giving different amounts of energy. It's giving exactly the same amount of energy to two objects. You say one of the objects collects twice as much energy as the other object collects. And that's the part you haven't proven with a single experiment in the history of mankind. All right. The F from the spring is K times D is the amount of compression. Constant. The more it's compressed, the more force. Yeah, so what? This means absolutely nothing. The more you compress into a magnet, the more it pushes back by the inverse square law. So what? The magnet always gives back the same energy for the same depth. That's all you care about, is that you have a consistent knowledge of how far it compresses for a certain amount of energy. The fact that the first inch is this big, and the second inch is a little smaller, and the third inch is a little smaller, and the third, because it's so perfectly proportional, it's still a very good ruler. Just as scales prove. Scales are adjusted to recognize that difference in the compression. So the scale has equal markings all the way around it. But the spring isn't compressing an equal amount. But the weight will be proportional to the compression in the spring. So it all works out just fine. And it has nothing to do with you saying, energy is m 1/2 m v times v. Yeah, has nothing to do with you putting velocity in the equation twice. Okay, when released, it shoves the other way, of course, and discharges first a strong force going to zero as the spring extends fully. Yeah, again, the fact that the spring pushes less the further out it gets has nothing to do with the fact that it does push on the object. As long as the object isn't lighter than the spring will be able to impart all of its energy into the object. So as long as the object is heavier than the spring, it's going to collect the energy from the spring. If you do the math, fuck this again. The whole thing in question is the integrity of the math. The math is crap. So the whole thing on trial is the math. You can't say, well, believe my fake evidence so you can see my fake evidence. Look through my fake microscope so you can see my fake gun. No, I'm not going to do that. I'm not using your fake tools. Show me the experiment that demonstrates you to be correct about any single thing. Show me one example of mv squared getting a proven right answer. That where you actually measured the value, where you actually did the experiment and measured the value. Drop the butter and show me that its weight is what mv squared says. Well, that's not a great example, but anyway, but you should be able to do that. Let's see. If you do the math of the total changing force over a compressed distance, the total force times distance is 1/2 k. You just keep saying the same shit over and over and over and over and over again. Of course, how much you compress the spring will decide how far it goes, but none of this squared crap has any relevance whatsoever. It is 1/2 because the force is going down in a line as it expands, so it is half what it would be if the force stayed constant from the starting push. Well, that average is already a known average, so who cares? We can do this. We don't need to do math. We can just compress the spring and see how much it weighs on the scale, how much the pressure is. Why do I need this? I don't need this. Let's see, and you can solve for v given m and m for a given v. So why don't you show a real experiment where you did this? And you'll never find one because there is no such experiment where velocity is squared. All right, from the kinetic energy, and you can solve for v given m or for m given v. Yeah, we don't need to solve it. So I'm just saying you have no experiment and your solution is for some vague notion of some experiment. What's the point of that? You proved nothing. You demonstrate nothing. You can't even use something like a stick of butter and make an assertion that the stick of butter has a certain velocity, a certain amount of energy, and that if I have something else with somehow in these conditions, like I said, I can't do it in gravity. Gravity is not going to give me. Gravity is going to accelerate things at the same rate. They can't go different velocities. So I obviously can't use the same conditions and create the same outcomes for things of. I can't compensate for doubling the mass. Okay. Without changing the height from which I drop things. But that's gravity. That's not every force on Earth. Lots of forces produce consistent amounts of force. Like a spring. Anyway, there's just no point. You're too stupid. All right. Let's see. Kinetic energy. And you can solve for v and m. Given v, you know the momentum, which has a direction and therefore extra information. So this is just silly. It's mv versus 1/2 mv squared. We know there's no direction. Nobody drew arrows over anything. We know they all have direction. So why are you pretending these MVs over here are special and they don't have any direction, and these MVs over here are special, are different and they have direction? That's just goo. Absolute goo. It's just drooling on me. It's so silly. Okay, damn, I did answer you. No, you haven't answered any of it. None of it. You 100% transfer the momentum, yet you lose half the energy. How can you transfer 100% of something? All the paint went out of the paint can and went on the wall. But somewhere I spilled half the paint. Now, if that isn't a paradox, what is it? All right. I mean, it's too stupid. That's what it is. It's just too stupid. T-O-O-O-O-O-O-O-O. Fucking stupid. Yeah, whatever. The only thing in my interest... let's see. Okay, I did answer you, but really it's going nowhere. Well, it's going nowhere because you're answering not a single contention made. I'm contending the formula was poorly scrutinized through its contrivancy. Through the process of it being contrived, there was very poor scrutiny. And it was accepted for no good reason. Okay? No evidence that momentum gets wrong answers. So we have no experiment that shows, well, momentum doesn't get the right answer. None. So we have absolutely no reason to create a new formula that just does wooey shit. It doesn't do anything productive. It doesn't enhance knowledge. It doesn't get right answers except one time a day. Like a broken clock, it gets the right answer once a day. That's it. 99% of the time, wrong answer. All right. Going nowhere. The only thing in my interest is to get you to understand the claim on the other side. That's why I've just spent all this time reading all these historical papers and all of these documentations, and I do understand it. They're overtly believed in free will. They overtly believed in that the universe isn't three-dimensional space. Okay, they are overtly hostile to Descartes, Cartesian, and Newtonian physics. Overtly hostile. What's to understand? They're religious kooks. Damn. All right. What you're saying about what we believe on the classical side of physics is wrong. Well, it's perfectly accurate. So you won't show any real history document. You won't show any statements made in the past that are going to show how, oh, this was a really brilliant idea. All you're going to be able to find is really poorly constructed experiments proving it. Really, really poor experiments. Dropping objects into clay. Dropping objects into sand. Specially created experiments that give a funny result. That's all you're going to find on your side. You're not going to find any credible physics. None. Zero. All right. Okay, let's side. What you're saying about what we believe on the classical side of physics is wrong. No, you obviously hate Newtonian physics. You hate a mechanical understanding of how the universe works. You really have no understanding of energy conservation. You have no understanding of motion as being all you're conserving. Is motion. The movement of something. All right. Slanderous even, he calls it. No, your erroneous characterizations that I have somehow not answered your questions, or somehow I have some obligation to explain why distance has nothing to do with it, when it has obviously nothing to do with it. Again, in the kinetic ball example, we know the amount of distance being traveled through the acceleration and deceleration process. That amount of distance is so infinitesimally tiny that you couldn't possibly apply it to some equation about the gigantic amount of energy compared to that tiny amount of distance. You can't measure the distance. You can't know what the distance was. How could it possibly be relevant to the fact that you transferred an amount of movement? And that's what you did. That you can overtly see it. Why do I care how much distance the acceleration took place in? Energy is conserved. Momentum is conserved. So again, these are statements overtly made by the other physicists that they're arguing with you. They will tell you, no, it isn't. They'll tell you, one guy will say momentum has to be conserved. The other guy will say energy has to be conserved. And they will overtly say things like, well, momentum is always conserved, but you don't have to conserve the energy. They'll say that overtly. Even the one financed by Microsoft, right? Whatever that is, Khan Academy. So you don't watch any of these videos. You don't know what they're saying. Because you're in conflict with what they're saying with that statement. All right, momentum is conserved to a degree. Okay, this is the funny one, right? The one that always really there's no way not to conserve momentum. Is conserved to a degree except when it's drained away to some energy storage. So here we go again. You don't call friction energy storage. I mean, nobody really does. It has to be it's leaked away. And the key word is, it's not about storage, it's about another form of transmission. If I transmit it through sound, that's a transmission. That's another transfer of the energy. I transferred it to the atmosphere. I transfer it to the rails of the track. I transfer it to the earth. I transfer it to something else besides cart A and cart B. Okay, so it's just another transfer. Energy always has to be transferred. Now you can transfer it to the object you want to. You can pour it into the bucket you intend to pour it into, or you can spill it on the ground or splash it in the air or make it go somewhere else. But those are your only choices. The paint always has to go somewhere. It can stick to the bucket you're pouring it out of. You know, it's always going to be somewhere. And you can't paint it all on the wall and then say, I spilled half of it. Shit. This is too stupid. All right. You have not shown someone specifically claiming a paradox. So again, I have played the video 4 times now. I'm not going to play it a 5th time just for you. Obviously, you don't want to watch these videos. That's fine. That's your prerogative. They have titles in them, Physics Girl, blah, 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 blah. The paradox is quite obvious. I've accurately described it and I've accurately stated what it is, and you have not countered it in any way whatsoever. So to claim that the paradox doesn't exist because you haven't seen it, fuck you. That's just a lame excuse. I'm not lying about what she said, okay? You offer a narrative. It's not a narrative, it's a description. And the description is 100% accurate. I'd stake my life on that. I'll give you, whatever, $1 million if you can prove I inaccurately described her exact words in any meaningful way, misrepresented what she exactly says, and what lots of other physicists exactly say. I don't care what Physics Girl says. So again, now you're just evading, obviously, aren't you? So here it is. There's a fundamental statement about what the physical reality is. I'm contending that physical statement, that reality, that description of reality is so freaking inaccurate, it's childish. A child could see how stupid it is. I painted all the paint on the wall, but I spilled half of it. It's so fucking stupid, even a 10-year-old wouldn't fall for it. He's not going to believe I put all the paint on the wall, but I spilled half of it. I poured all of the paint into a bucket, but I spilled half of it. There's 1 gallon of paint. I put the gallon of paint in the bucket without even pouring it. I just picked up the paint and put it in the bucket. And then I tell the 10-year-old, and I spilled half of it. Fuck you. That's overtly what's being stated. Overtly. No doubt about it. It's the exact concept. Nothing's missing. That analogy perfectly describes the assertion. Okay? 100% complete transfer of the paint. And yet I spilled half of it. These are physics videos watched by millions of people, asshole. Okay, these talking heads of physics. I can find 50 of these videos that make this exact assertion. Okay, and if you total up, it might be 50 million people have seen that bad physics, rotten to the core garbage physics, pseudo bullshit physics. It's important, idiot. You don't care. I do, and it's the subject that I'm arguing. You don't want to argue the real subject. You want to argue some other subject. All right. You don't like that way of thinking about it, but it doesn't matter. No, it matters that you haven't made an argument or presented one piece of coherent evidence. And the one thing you did give me as a piece of evidence was actually evidence on my side, was actually making my point in a childish video where they basically said, look, the bowling ball has more momentum. But look, the bullet has more energy. And that's the dualism you believe in. You believe that is somehow not a contradictory statement. That something can have more momentum, but less energy. You think that somehow makes any sense anywhere in the universe except in silly people's brains. If there were aliens, again, they would be mockingly laughing their asses off that fucktarded humans could believe in something that stupid. Oh, it has more momentum, but less energy. Somehow. Too stupid. All right, kinetic energy and momentum are directly intertwined. So this is two different answers to the same question is complete symbiosis of the poo and the shit. I mean, it's just such baby talk. What's the problem? Yet they're different answers is the problem. You can't say it weighs 5 pounds, but it weighs 7 pounds. It weighs 5d7. 5d7. Sometimes it's 5d22. Sometimes it's 3d44. I'm a smart person. Fuck. Just, what's the problem? It's a marriage mode in kinetic heaven. So yes, maybe he's being funny, but it's not funny. Because it's so true. It's exactly how you people think. Your little goo brains. People wanted to know how much fire could move. Here we go. We're back to this shit again. Move an engine. It has nothing to do with square and velocity. No reason to do that. With 10-ton load. How much momentum is in a bunch of wood you are going to burn? It doesn't really matter because half of what you're burning is going out the smokestack anyway. Anyway, so you're not going to figure it out by weighing the wood. Oh, what an idiot. Turn into boiling water, spin turbines, and drive locomotive thruster. That's what led to this. No, that isn't what led to this. This is just such a lie. This theory was invented 100 years before the steam engine. It's just a gross lie to say this has something to do with steam engines. And why it is called Joule momentum. By who? It's called a Joule momentum. Remains a basic concept. For who? Show me the video where somebody's talking about Joule momentum. Anyway, in its own right with information. Now he's talking about the information theory. Okay, that isn't in the amount of energy. What's the point of acting like it's a competition? So let's understand. All of the papers, the original papers written to defend this, were entered in a competition. The competition sponsored by the French to debunk or falsify Newton. That was the whole point. They had two of these competitions, where they entered papers to try to prove Newton wrong. That was the whole fucking point of it. It was a competition. Oh, amazing. They could have been called anything. What I was taught about work in college physics, the professor even said, la 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 la. Who cares? Walter Lewin says silly things like the, standing waves don't, blah, blah, blah. I could go through all those silly things. Professor Lewin thinks there can be two voltages in the same location in physical space. Where were we? Let's see. Own right information that isn't the amount of energy. What's the point in acting like it's a competition? They could have been called anything. We're not arguing about what's being called something. We're arguing about whether energy is there's two numbers. Momentum gives a number, kinetic energy gives a number. The numbers aren't the same. That's a problem, dummy. God damn it. When I was taught about work is just the inverse of force, right? I mean, there is no such thing as some, what's the work is how much you're fighting a stream. How much you're fighting something that has an opposite component to it. There's no work if there's no opposition. So the work is just defined by the opposing force. In college physics, the professor even said, don't think of whatever you mean by work. This is that word chosen for this particular concept. And it's a perfectly good concept in the sense that work is opposing a force. You're opposing gravity, the work to lift something. You're opposing gravity. That's the work. You're opposing the electrodynamics of substances when you do work with banging rocks and breaking the rocks. You're fighting the charge forces that are holding the rock together. Pushing at a certain force for a certain distance. So again, this just has nothing to do with any of this. And the reason was they wanted to push things at certain forces over certain distances because they were applying physics to engines and invented thermodynamics. So again, he says that this is somehow critical, that you forget, you ignore momentum and use their kinetic energy formula, and somehow it gets better answers. It doesn't ever get a better answer. He'll never show me it getting a better answer. The momentum is involved. So again, more baby talk. The wrong answer is involved in the right answer. How so? But they are literally asking how much wood energy for how much pushing things for a distance. So again, we know you can't even get the energy out of wood anywhere near peak efficiencies. The efficiencies are really poor. And my narrative is that fit perfectly well with momentum. So again, the two numbers are different answers for the same question, and he keeps saying the wrong answer fits just fine with the right answer. They're perfect friends. There's absolutely no problem. Wrong answers, best friends with right answers. Never in conflict. It allows you to know how much gasoline. So again, momentum allows you to know that. Kinetic energy gives you the wrong answer. Anyway, you would burn to turn the motor and get something up to a certain speed based on the mass and the amount of energy. So again, if you use your formula to decide how much energy anything has, you'll get the wrong answer. You'll preposterously exaggerate the amount of energy because you don't understand that the lighter thing going fast has exactly the same energy as the heavy thing going slower. And it's just a fact, and it'll always be a fact, and in every experiment it's going to be a fact, and you're never going to show that extra energy you think the lighter thing has. You'll never collect it ever, 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 ever. You'll never show me you collecting more energy from a bullet than from the bowling ball. You'll never show the experiment where you collected the more energy. Except maybe by rolling it into clay. Yeah. You might be able to fool clay, but you're not going to fool somebody with a brain. All right, that's enough. Oh, so tedious. So, if I haven't said it lately, I do despise my existence on this planet of fucking lying sack of shit, belligerently stupid morons. I really hate it here. You people really do suck at logic. You obviously hate facts. You hate fair fights. You just love, completely perverting the subject to how wonderful your God is. Because you're all a bunch of religious kooks. Clearly. Anyway. Alright, so that's enough. I'll get the hell out of here. So, this has been a DraftScience video presentation for your enjoyment and such.